Hello, everyone, and welcome to our next installment of our webinar videos with Research Aromatica. This is our 8th video we've done since earlier this year, and again, very excited for the content that we'll be learning today from one of the experts in this industry. As I introduce our guest, I did want to say that Florencia and Beta Analytics is someone that from a aromatic plant research center perspective, we've worked with for a number of years and have been very pleased with the work that they do as we at times send samples out for Carbon-14 and other radiology testing and being able to determine purity, but also look at a number of other aspects of the samples that we look at, and Beta has been a great partner in that. So to introduce Florencia, Florencia Goren joined Beta Analytics in 2011, and Beta is the world's largest radiocarbon laboratory. At Beta, she has implemented growth strategies to increase market share by spearheading both their business development and marketing departments. In doing so, she successfully expanded Beta's global presence, now holding a footprint in all major continents. Prior to her time at Beta, Florencia Goren graduated magna cum laude from Florida International University, where she pursued a double major in international relations and geography through an honors track. In 2011, Florencia obtained a Master's of Science in Nature, Society, and Environmental Policies from the University of Oxford. She currently holds a position of Vice President of Corporate Development and Strategy from Beta Analytics. We're very excited to have Florencia here with us today to introduce us to the concepts of radiocarbon testing and how it applies to natural products such as essential oils, but also other extracts and natural products. So Florencia, if you'll join us here now, and we are excited to go through your presentation.
Thank you, Aaron. I'm very happy to be here. Thank you for the invitation. I'll start. There we go. All right. Well, welcome, everyone. Thank you for joining us today with this webinar from Research Aromatica. I'm very happy to have you all here to learn a little bit more about Carbon-14 and how to use that to verify naturally sourced ingredients. Before I start, I want to give you a quick introduction of Beta Analytic. We are one of the world leaders on radiocarbon dating. We've been in business for 40 years, and aside from radiocarbon dating, we are expert in other applications of Carbon-14, for example, for biobased testing, naturally sourced analysis, and then also biogenic testing. We do as well stable isotopes such as carbon, deuterium, nitrogen, and oxygen. We're an ISO 17025 lab, and that's one of the highest standards that a lab can obtain. And we are approved by multiple international certification programs globally. So today I'm going to be going over how Carbon-14 is formed, how is it measured, its application on radiocarbon dating, biobased testing, then as well the application that is relevant to most of the participants here today, naturally sourced ingredients, some of the technical standards, organizations that accept C14, and finally I'm going to close it with 2 case studies that are aimed at help you understand how Carbon-14 works in the application for essential oils. So let's start with science. So Carbon-14 is formed in the atmosphere. It's formed from nitrogen and cosmic radiation. C14 is then absorbed into CO2, or is incorporated, to use a better word, into CO2. And anything that is a living organism will absorb that CO2 with that Carbon-14 signature. And then when that living organism, that Carbon-14 is going to decay and go back into the atmosphere as nitrogen-14. So why does it decay and why does it go back into the atmosphere? Is that because Carbon-14 is a radioactive isotope, and it has a known half-life of about 5,700 years. So it is a known decay rate for this isotope. So how is it measured? So how do you measure an isotope like Carbon-14? So Carbon-14, when you're looking at carbon in total. It's very small in quantities and its size. So you need a special machine to measure it. We use something called Accelerator mass spectrometer, or also known as a particle accelerator. These are machines pretty big. They're about the size of a room. And they are specialized to measure such a small quantity of an isotope like carbon-14. So if you send a sample to a laboratory, what does that sample look like when it goes to that machine? And to give you a little bit of a better idea what it is like, so you would convert that sample into graphite, which is the purest form of carbon. And you can see that on your left-hand side picture, this black powder. Then that goes into tiny, tiny little targets. One of each of these targets in this wheel, it's one sample. And then that sample gets loaded into an AMS machine. And then the AMS machine is going to shoot those samples and count the isotopes in them. So now that you know how it's formed, how can we measure it? So where do we use it? And the most traditional application for a carbon-14 isotopes is radiocarbon dating. And that's primarily used in archaeology and geology. And it's used because of the known rate of decay. We can establish the age of materials that have carbon content that are within the 50,000 year range. And 50,000 is when that carbon-14 decay rate is over and there is no more carbon-14 left. So a question I like to ask here, and something to keep in mind for future slides, is how old are petroleum-based? How old is petroleum? It's 1 million years old, so there's absolutely no carbon-14 left in it. So how does it work in archaeology and geology? It can help, say, an archaeologist in a field work. They do a dig. They can find, let's say, a bone. They want to establish the age of that. They would send it to a lab, and the lab would analyze it for that carbon-14 content and determine the age. Let's say in geology, you have a volcano and you want to establish the chronology of the different eruptions. You can measure in the different layers the carbon-14 of the material found there and determine how often and the age and how often it happened. So very powerful tool in those two applications, very widely used, very well-established application globally. Our next application is Biobased, the Biobased side. And this starts to align a little bit more and more with this audience. And before I go into how this works, I want to first explain what Biobased is, and that means any material that is made either in part or in whole from biomass resources. So when you're talking about Biobased percentage, it means out of that material, the total carbon in it, how much of the total carbon is coming from biomass. So that would be the Biobased percentage of that material. So remember I asked you how old is petroleum? It's 1 million years old. There's absolutely no carbon-14. So here's where it's very important when it comes to Biobased and Biobased testing is that anything that is at that top level of that chart, where you're looking at the biomass, the actual feedstock, it has a known amount of carbon-14, and then it decays at that known rate. But anything that will come from petroleum has no carbon-14. So when you're looking at the two carbons, they're not identical. One will have that carbon-14, and then something that comes from fossil fuel like petroleum will have absolutely no carbon-14. So the question now is, how do we know how much carbon-14 is in the atmosphere, and what establishes that known rate? And this takes me to technical standards. And the first technical standard out there is ASTM D6866, was established in the early 2000s. This was a joint collaboration between the ASTM committees, Beta Analytic, and the Department of Agriculture here in the US. And this standard not only formalizes the use of the carbon-14 to measure biobased, but establishes that percent mother carbon in the atmosphere. And that's known as the reference value. This year, 2020, we are 100 PMC. And right now we are in the works of establishing the reference value for the future years. Aside from ASTM, we have multiple other standards globally. The ones that are more relevant for today's presentation are ISO 16620 and then the European standard EN 16640. They're all based on the Carbon-14 method, and actually these two are pretty much the same as the ASTM D6866, which is the primary standard out there. And this is how a report looks like. And I like to show this report because I want to show how easy it is to understand a result for bio-based testing and Carbon-14. It will give you the percentage of bio-based, but it will also give you the data if you need that. But it's very clear if you want to know, is it 100%? Is it anything less? You immediately know by looking at this pie chart. So where is the bio-based and the renewable carbon applications? You see this in all sort of industries and products, household products, personal care products, bioplastics. Some of you might recall the plant bottle from Dasani. That means that it's partially made from biomass. Then we have things like biofuels and then CO2, which are emissions as well. So to start off in these applications, I want to touch on the renewables and biofuel application. And this can be cement plants, waste to energy, biofuel producers, co-firing facilities. And how they use this is that they measure either the actual fuel or they measure the emissions from the gas tags. And they're looking at how much from that product is coming from biomass versus fossil fuel. Why do they do this? Can be for R&D, trying to determine what the product is going to look like. But sometimes, and actually in some places, most of the time, is because of government regulations that require them to report that percentage. In some countries, there are carbon credits, and they're trying to maximize those carbon credits, and also just to meet their own internal targets on greenhouse emissions. When it comes to the bio-based application itself, that's the bio-based products, and that's more commercial and consumer products, and now also expanding into industrial products that are made partially or as in whole from biomass or biological products. And these can be plastic, like we mentioned before, personal care products such as deodorant, hair care products, feminine care products. We see it also on things that are like construction material, car care products, packaging, and something that we're seeing more and more is also that expansion to use this term and this testing for intermediate chemicals as well. And what's key about this bio-based application is that there are a lot of different programs out there that certify that bio-based by using the C14 standards. One of the most well-known here in the United States is the USDA BioPrefer certification. This one will use the Carbon-14 test, and then they would determine the minimum threshold bio-based to get certified by product category, and then they will put the percentage on your final product. And this certification is very comprehensive. All the products that were listed on that previous slide, they're all certifiable by the USDA BioPrefer, and they have even a lot more in their website. Other certification programs are, for example, in Europe, you have the BINSAT, OK Biobased, BINCERCO. In Brazil, I Am Green from Braskem. And then there are other ones as well in Asia that do the same thing, the certified bio-based products by using any of the technical standards for Carbon-14. So this takes us to the final application, and the most relevant application for the audience here today is the use of Carbon-14 to identify naturally sourced ingredients, identifying if there is any sort of petroleum-based adulteration in your ingredients, and then also to substantiate any natural source claims. So this application is mainly affecting anything that's related to essential oils, flavoring fragrances, nutraceuticals, within the industry such as aromatherapy, food and beverage, personal care products, pretty much aligned with that bio-based certification type of program. So if you have, let's say, a body cream that has fragrance in it, if that fragrance is artificial, will affect your bio-based percentage. So pretty much aligned with that. And then also all sort of vitamins. So why is this something of concern to look at that natural versus artificial? Is because of that term that many of you might be familiar with, the economically motivated adulteration. So for those that are not familiar with this definition, is basically there is a potential for economic gain by adulterating or committing fraud on an ingredient. It doesn't have to be food specifically. It could be any ingredient that is naturally and could be made synthetic. So it can be a substitution, it could be a dilution, mislabeling, contamination, etc. So why is that a threat to the industry that uses natural ingredients? And that is because there's that increased demand for natural ingredients, and there is that willingness of consumers to spend more for those. And then there is the rising cost of natural raw materials. And it's not only the rising cost, it's also because producing something naturally by growing it, it has a much higher cost than doing something in a manufacturing plant or a lab. So all of the combination of all of that opens that door for adulteration and fraud. So we like to use this example, which is on the essential oils, is garlic oil, to show the difference and why is that economic motivation behind it. So in garlic oil, the artificial price was 161 per kilo, and this is about 2 years old pricing, so it's not up to date. But when you were looking at the natural at that time period, it was about 5 times the price of the artificial. So you can see very clearly the motivation there to pass something as artificial as natural. So when you have a situation like that, although there are a lot of testing that you need to do and are very valuable to your product, only carbon-14 is the one that is going to tell you, is that product synthetic or natural? Is it coming from naturally sourced ingredients, such as any part of biomass, or is it coming from petroleum-based materials? So when you're making the natural claim, what we like to say is, like, by using that carbon-14 and start testing early on, you're protecting your brand name. You're also mitigating any repercussions, such as legal, marketing, or financial. So you want to start identifying fraud early on. And this is something that most of our very proactive clients do. Immediately as they start establishing a new relationship with the supplier, they start incorporating the testing. And we have clients like This Work, who is a CBD oil company for personal care products. They test all the way through their supply chains, even to the moment that their product is going to hit the commerce, the shelf, basically. So it's a tool that can help you at any stage of the way, but we always recommend start early on, because you want to be able to pinpoint if there is any sort of adulteration or even contamination. You want to know that far in advance. You don't want to be the person with the product ready to go and then detect that there is a problem. And the application for carbon-14 in this type of industry is not new at all. In the 60s, Coca-Cola was already using it to differentiate between caffeine, natural caffeine and artificial. And then in the 80s, the Flavour and Extract Manufacturers Association started using this as well for almond. And aside from being very well established through the years, it's very well established in different organizations. The European Flavour Association recognizes carbon-14 as a robust tool to distinguish natural origin of the raw materials versus petroleum-based. Then we have the International Organization of Wine and Wine. They use carbon-14 to distinguish between natural wine vinegars and synthetic ones. The USP and their Food Chemical Codex have even gone a little bit far to just not using C14, but adopting one of the standards, which is the ASTM D6866, to test for food additives. And now they have expanded in their last chemical codex to all ingredients. So carbon-14 has been a very clear choice since the 60s. It helps you identify fraudulent ingredients. It will help you protect your brand name. It will help you mitigate any repercussions that might affect you if you have a product with artificial material and you claim it to be as natural. But for some people, the key thing is you just make sure that you get what you pay for. So if you're paying that premium price, such as in the garlic oil example, you're paying 5 times more for that ingredient, you want to make sure you're getting that ingredient. And with that said, I want to jump into a couple of case studies. Let me grab a little bit of water. So, of course, we'll start with that garlic oil case study. What we decided to do in the case of garlic oil, we picked 4 off the shelf garlic oils. By off the shelf, I mean we just bought them with different random suppliers. And they all had a claim on their label that they were natural products. And then the 5th one was our artificial one. So the first thing we did is we looked at the purity of the samples. We sent them out to Aromatic Plant Research Center, and they did the GCMS test. So for our first sample, GCMS came back really well. But once we put it in the carbon-14 test, this sample came as completely adulterated. It was all 100% for petroleum-based chemicals. The second one passes the GC. And then again, we have a case of adulteration. In this case, we have a dilution of the product by only being 67% of the material from biomass. The rest was from petroleum base. Our third garlic oil passes the purity test, and this is the only one that actually comes back as truly naturally sourced ingredients, being 100% bio-based. And I gave you the answer for the next one, passes the test. But when it comes down to carbon-14, again, this is a petroleum-based material. Our final one, we knew it was artificial. So when it comes down to the carbon-14, it comes back as artificial, such like the way we expected it. So the conclusion here is that only 1 out of 4 materials that we tested about 2 years ago was actually truly natural. Everything else was adulterated. So this is the power of carbon-14. It can easily spot where a product is adulterated or not when it comes to naturally sourced ingredients. Our next case study, just to also give you another example here, is with peppermint oil. There is that growing demand for peppermint oil, and we see this coming more and more to our laboratory. And in this case, what we did, we just grabbed 5 samples, peppermint essential oils. We bought them, actually, these ones from Amazon. And only 3 out of the 5 came back as truly naturally sourced, as their label claims. And then other 2 came back as counterfeited, well, not counterfeited, adulterated. One being diluted and the other one being 100% from petroleum-based sources. So again, carbon-14 here was very valuable in determining is this material really coming from a naturally sourced ingredient, or is it coming from a petroleum-based source? So now that you've seen how it works and how it can help you detect economically motivated adulteration in your products, how is it to test this? How is it to do it? I mean, you don't need to buy a huge machine. There are a lot of labs that specialize on this. And we are here at Beta Analytic. We're one of the experts in the industry, and we can accept your samples, and we only need a few drops. We need about 3 ml of your sample, so you don't have to invest a lot of material there. And we can test it within 5 to 7 days. You'll get your report online in our secure portal. So very easy to do. And if you have any questions, you can ask me later on that process. So to conclude, what did we learn here? And I hope you all learned something today. How carbon-14 is formed, how is it measured, international standards and application, how carbon-14 can help you prevent economically motivated adulteration. And finally, we presented two case studies with essential oils that are aimed to provide more clarity on how it works. And these are real case studies of things that we grab off the shelves. So with that, I leave you here with my contact info, and feel free to reach out to me directly. Email is always better, but my phone is there as well. And also, please take note, Beta Analytic is a global company. We are located in multiple places, and we have a multilingual sales team that can help out in different countries. And with that, Aaron, we can open the Q&A. Thank you.
Thank you so much, Florencia. That was great. And I guess to start off the Q&A, I had a bit of slip of the tongue at the beginning there where I said carbon-14 testing. So maybe we start off there. What are the differences between carbon-12, 13, and 14, and any of the uses that they may have in testing there?
Right. So carbon-14 is what you will use for differentiating is it naturally sourced versus petroleum source. Once you are in the natural realm, you want to use, in addition to that, carbon-13 to determine the plant type. And that can help in cases where you are looking at not only verifying is it from biomass, but is it from the right biomass or is it from the right plant? And then there are other isotopes that can help support that even better, like deuterium. And that's something we're actually going to be launching within the next 2 months as well. And I'll be more than happy to present on that one too.
Excellent. Thank you. That would be great. So we do have some questions here. One from Dr. Satyal. He asked a question that if a plant was nourished in fully synthetic, whether the fertilizer, perhaps the CO2 or other nutrients were petroleum-based, what would that do to the plant itself, and what would be its carbon-14 ratios?
Right. The signature of carbon-14 will be affected. And this is something you can see in algae that is grown with CO2. For example, to try to kind of capture that CO2 emissions by growing algae with it. That type of fuels, that are algae-based fuels, C14 would not work because most of that CO2 that the plant is absorbing is going to come from fossil fuels. So there's going to be no C14. But those are very specific scenarios.
Sure. And it's like with anything else, there's no test is a perfect test to determine everything. And so every test has its limits of capabilities. And certainly that's one to consider there. So when you talk about being able to certify if products are natural or not, how often do you see people adding or trying to alter the C14 isotopic ratios to kind of meet the expected standards that are out there that you also mentioned?
Well, seeing that they're trying to alter, we don't see that. We test more people that are trying to catch adulteration in their products. And we test all over the world constantly. Fortunately, most of the people that test are very proactive. So they generally are the ones that are less of a victim to that adulteration. But it takes, like the example I gave with this work, they test everything and they're very proactive. And that's generally where you see when people are very proactive and they have that really open relationship with their suppliers and they know that they're getting tested, you see less and less adulteration happening.
Great. Yeah. Good. Yeah. So it's another layer in continuing to fight or to make accuracy in label claims. And as you said, ensuring that people get what they're paying for.
Yeah.
So let me ask, what's the level of accuracy? I mean, you said a lot of these petroleum-based, the fossil fuels are millions of years old. How accurate can you be in being able to say, okay, it is 50,500 years old, or what's the range you can say with accuracy how old a sample is?
Right. So the older it gets, the statistically, when you talk about radiocarbon dating, that's gonna grow, like the age range. When it comes to biobased testing, the standard for the percentage is plus or minus 3%. So to anything that will be 97% biobased is statistically consistent to what will be 100% biobased. So it's within the error range per the standard. Some of our clients sometimes test outside the standard and they want to get a narrower result many times doing 2-3 times the test when you're talking about when you're trying to detect very little bio-based, let's say a contamination in your product line or anything like that. You can do multiple tests and do then the math and the calculations to narrow that down.
I see. Yeah, that makes sense. Okay. That does, I think that answers one of the other questions, but Liza said, would a 92% carbon-14 result be sufficient to claim natural? It sounds like your set there is 97 to be able to claim fully natural.
Right. 97 is what the standard allows. 92 wouldn't be considered natural per the standard.
Okay. And does it matter the type of product, or is that ubiquitous across any type of product to claim that?
It's any type of product. So unless you have a case where let's say you're growing garlic next to a coal plant, and you know that the coal plant is emitting CO2 right next to it, which is very rare. I mean, to have that one next to a coal plant. Then the best thing that you can do is you send the actual raw material to establish the reference value for that raw material, and then you test the end product, and you can narrow it down. But generally, that's more in a scientific type of research, not something that is used on this as a general rule.
Yeah, sure. As a regular testing protocol. Good.
Right.
There is a question too. Can you give a range of price for what this type of testing would be to test for natural products?
Right. I'll give you a range. It can go between 400 to 700. It depends on the material type, the product, the quantity of samples. I mean, there are different factors that you have to consider.
Okay. Okay. And Dr. Julian did also talk about pricing, and yes, there certainly are different prices for natural and synthetic. We do recognize that too. He does also ask about testing with tritium, or if you're familiar with that.
Tritium, I'm not familiar with that for natural sources. I'm more familiar with tritium for water testing, but not for that.
I see. Okay. Okay. And looking at some of this here, can the test results show 100% expected C14? How can that be interpreted if it's less than 100%? And between the 97 and 100, is it just considered fully natural at that point, I think is the question.
Right. And if you have anything less than that, you can consider multiple things. Are you having a problem with dilution? And then another thing that people sometimes forget to factor in is contamination in your process, which you could have as well.
Okay. Okay. All right, and I'll answer another question, or read another question here. It says, flavors have a regulatory definition of natural. They are often high in purity and distinct chemicals. What's the minimum C14% or biobase that meets the U.S. regulatory definition? And how does this compare to the EU regulatory definition? So country definitions, and how that differs.
So they're very different. In Europe, there is a natural definition, and it's more comprehensive than here. It doesn't necessarily says carbon-14 in it, but it does says they have to come from biomass sources or biomass material types. In the US, the only definition that there is for flavoring, and that's on the Code of Federal Regulations Title 21, and they define flavoring basically the same way. It has to come from biomass or from animal products. They don't allow anything else. And one way you can test is it from biomass or animal products is C14, because it will give you that clear difference. Now, when it comes to broader definitions outside flavoring, there's none. The FDA did try to do so about 4 years ago. They actually opened even for public comments that quest. But the situation with natural is that the world is so broad that people have a lot of different definitions. So people want to stick the organic to it. The GMO, is a GMO really natural? So that's it's very hard to define natural. So in this application, we define it simply as, is it coming from biomass or is it coming from petroleum? And that's what carbon-14 answers. That's it.
Sure. Yeah. Yeah, and that's great. It's good to realize, the very specialized, is it a petroleum-based chemical or product, or did it come from a more recently grown plant-based product? Very good. And then another question here, can the means in which you sample impact the results of this C14 testing?
Well, you do definitely want to do it in a clean environment, you don't want to touch the material. So if you have a powder, you want to use clean material, nothing that has any sort of grease, say anything that you got to think about. Anything that might have carbon will contaminate it, especially if it's a liquid or a paste. Generally, what we recommend is using a glass vial with a cream top cap that prevents the liquid coming out of the material. For C14, for example, putting in a Ziploc bag is fine because it's something that is not going to transfer any carbon into the sample. But when you're talking about liquids and how you sample, you want to make sure you're doing it with clean materials.
Okay. Mm-hmm. Yeah, because I could think we often see if an essential oil, for instance, is stored in an improper container, like a low-density polyethylene, we can see even very significant amounts of phthalates or plasticizers get leached into the oil. I would assume you'll be able to pick those up in a C14 test.
Yep.
Yep, definitely. Okay.
And that's why C14 is also used for the contamination, to see if there's any traces in your process.
Okay, great. Another question that just popped up here is, how does the Biobased method compare to other natural testing methods, such as site-specific DNMR or stable isotope ratio analysis?
Well, a stable isotope ratio is what you asked me earlier today. It's about the C13. The C13 is not going to tell you is the plant natural or not. The product. The C13 is going to tell you, once that product is natural, where is it coming from in terms of plants? What type of plant material is it? Now the FDA is, and I need to read more into it, have a new mandate of clearly stating what is the source of the sweetener in the products. So let's say if you have honey or if you have sugar cane or any other sort of material like agave, C13 and stable isotopes will help determine which one is it. They're all going to be natural, but which one is it? That's where the C13 will come into play. The other question on site, I mean, if you have anything that is organically grown, I mean, there are those type of on-site auditing and things like that. There's no need to test that. I mean, you know that it's going to come from a plant. This is really more for products like an essential oil that you're not necessarily right there on the field where it's getting produced.
Excellent. Yeah, and that does answer, looks like our final question here. The C14 in testing, yes, is commonly used in essential oils, but other extracts and many, many other natural products to determine if they are natural or not. So,
right.
Yeah.
Something we do a lot outside the essential oils for the same application is nutraceuticals. And one of the key products that we get is curcumin. We probably get curcumin every single day to test.
And if you could maybe generally answer this question, but with all the testing that you do, how much of those products that I suppose would be intended to be natural, after testing, do you see that there are petroleum-based products in there?
Oof, out of the top of my head, I don't know exactly. But I'm trying to think of one of our like heavy core users, maybe about 10%. Okay.
Okay. And you can see from your case studies here, the garlic oil, all 4 of them were adulterated, and nearly half of the peppermints that you looked at. So it certainly is a concern in why so many people utilize this type of testing to ensure that their products are absent of petrochemical products.
Yeah,
definitely. Well, thanks so much, Florencia. This has been a lot of fun. I've learned a lot. And really appreciate your time today and all the effort into the presentation. I really enjoyed it.
Thank you. I appreciate it.
Yeah. Take care, and perhaps again we can have you on to talk about other ongoing testing and means that you're developing.
Yep, sounds good. All right. Okay. Well, thank you, everyone.
Thank you. Enjoy the rest of your day, everyone.